Okay, let's talk about piecewise defined functions. These are simply functions defined in pieces. So if we take a look at this example here, we have f of x equals. So just like other functions, we have f of x equals something, except in this case you see three pieces. Sometimes there might be two. Here there's three pieces. Other times there could be more. So how do we know which piece to use? Well, it's all dependent upon over here, which tells us the different intervals for x. So if x is less than 0, we're going to use the piece of negative x. So if I wanted to plug in anything less than 0, such as negative 3, if I plug negative 3 into this, I'd get a positive 3. So I would use this piece for anything less than 0 for x. If I'm talking about x values between and including 0 and 1, I would plug into the piece of x squared in order to get my output, or my y value. For any x value greater than 1, it tells me here that the output is just going to be 2. There's actually nothing to plug into. So we're going to take a moment now and graph this. So we set up a very basic looking grid here. So let's start with our top piece. We need to graph negative x for x values less than 0. So just think about graphing y equals negative x. We know that that's a line with a negative slope. So y equals negative x would be coming downhill until we hit 0 here. Now at 0, notice 0 is not included. Okay? 0 is not included. So we want to have an open circle right there at the origin where x is 0. Okay? So I'm not going to keep going into the fourth quadrant because it's only defined for where x is less than 0. Next we have to draw x squared, and we're only going to draw x squared between 0 and 1 for those x values. So if I plug 0 into it, notice 0 is included here as well as 1. If I plug 0 into x squared, 0 squared is 0, and that happens to be at the same spot here where the last one ended, so that open circle that was temporarily open, now it just got filled. Let's go to the end where 1 is. Okay, if we plug 1 into our piece here of x squared, 1 squared of course is 1. So now between these 2 points I need to just draw a little portion of what x squared would look like. So I have a closed circle there. And finally, the y value is going to be 2 for x values greater than 1. But 1 is not included. So up above here I need to have an open circle at 2, and then if you think about graphing just y equals 2, that is going to be a horizontal line. I'll put arrows here on the ends. Okay, so notice this function is not continuous because right here when x equals 1 we have a jump. Okay, let's take a look at another example here. In this example, let's work the other direction. Suppose we are given this graph. Alright, this is a graph of f of x. And we know that we have a closed circle here at the origin. We have an open circle at 1, 1. Closed circle right here at 1, 0. And then another closed circle here at 2, 1. We wish to write an equation for this graph. Okay, so we have to look at each of these individual pieces. The first piece appears to be defined between 0, including 0, and 1, but not including 1. So let's start by just leaving some space, and let's write down the x values where this is defined. So it's defined between 0 and 1, including the 0 and not the 1. And likewise for the next piece, we can see that it's defined between the 1 and the 2, for these x values, between the 1 and that 2, and both are included. Well, these are clearly lines, and if you look at the slope here, your change in y over your change in x. With our first piece here, it's going through the origin. So this is just going to be y equals x, so we're just going to write x for that piece. The other one, if we were to continue it on down to look at where the y-intercept would be, this would be x minus 1. Again, the slope is positive 1. Okay, so that's consistent with each of these, but the y-intercepts are different. Okay, and finally, consider the function f of x equals the absolute value of x. We know that with the absolute value, the graph is our V-shaped graph. Well, this could actually be defined in a couple of pieces. If we were to think of this as having a left side and then a right side, we can define this in two pieces. The left side has a slope of -1, the equation would be negative x, and that is for x values less than 0. The right side can be expressed as y equals x, so we just write x there since it has a positive slope of 1, and this is for x values greater than or equal to 0. Now, as far as where you put that equal sign, you can put it in either location because, as you can see here, they meet at the origin. Okay?